Welcome to Spring LIB.
Modulus is equal to the tension times the initial length divided by the area times the change in length. We also know that the velocity of the wave is equal to the square root of the tension divided by the mass per meter length. We also know that mass per meter length is equal to the density times the area. We're given the density to be equal to 2.7 times 10 to the third kilograms per meter cubed. We're given the cross-sectional area to be equal to 5 times 10 to the negative sixth meters squared. We also know that Young's modulus is equal to 7 times 10 to the 10th newtons per meter squared. Solving your velocity equation for t, we get that t is equal to v squared times the mass per meter length. Next, plugging this into Young's modulus, we get that the length times the velocity squared times the mass per meter length divided by the cross-sectional area times the change in length. Next, since we know that the mass per meter length is equal to the density times the area, we see that the area cancels out and we're left with that Young's modulus is equal to the length times the velocity squared times the density divided by the change in length. Then plugging in our known, we get 7 times 10 to the 10th is equal to 100 squared times 2.7 times 10 to the third times the length divided by the change in length. This gives us that the length divided by the change in length is equal to 2,592.59. Then take each side to its exponent. We get the change in length divided by the length is equal to 3.857 times 10 to the negative fourth.